Welcome back. In the last part of this lecture, we'll now be graphing polynomial functions, and we'll do that by looking at our intercepts, finding the behavior at the x-intercepts, finding the end behavior for our polynomial, and then putting together all of our clues. So first off, the x-intercepts. Those I can read directly off of my polynomial since it's already in factored form. So if I were thinking about my zeros, I can see that I've got 3 of them. X could be 0, or 2, or -1. Those are the possible values of x that would make our polynomial equal to 0. In other words, those would be our x-intercepts at 0, 0, 2, 0, and -1, 0. And of course, the next thing to do is to talk about our multiplicity and the behavior at the x-axis for those points. So for x being 0, that came from x cubed, whose multiplicity is 3. X being 2, that came from x minus 2 squared, so multiplicity is 2. And x being -1, that came from x plus 1 to the power of 1, whose multiplicity is 1. And remember that when the multiplicity is odd, we'll be crossing the x-axis. And that where the multiplicity is even, that's where we'll be touching the x-axis. Now, one other thing that we can do is find out our y-intercept and to also find our end behavior by looking for our constant term and our leading term. And so maybe I'll do that up here. So for our leading term, again multiplying together the leading terms of all of our factors, that would be x cubed times x squared times x, which is x to the 6. And for our constant term, multiplying the constants of all of our factors, the first factor, the constant is 0. The second factor, the constant is -2. The third factor, the constant is +1. And that is just 0. All right, so the constant term tells us that our y-intercept is 0, 0, but we kind of already knew that because we have an x-intercept of 0, 0. So that x-intercept is also that y-intercept. The other part, the end behavior, that we find by looking at the leading term. The leading term is x to the 6, so our end behavior should be the same as the graph of x to the 6, that will be going up on the far right and up on the far left. Okay, so now I'm going to do the graphing part of this. And so what I'll do is first plot my points, and here I only have 3 points. I have the point 0, 0, that's the x-intercept, which is also the y-intercept. I've also got the point 2, 0 and -1, 0. So I've plotted my points, and that's all the points that I have. The next thing that I have to do is start filling things in, and I'm going to first put in my end behavior. I know that on the far right I'm going up, so after my last x-intercept I must be heading upwards. And on the far left I'm going up, so to the left of my last x-intercept I must be going upwards. And then for the middle part, I will use the behavior at those x-intercepts. So, reminding myself that at -1, we're going to be crossing the x-axis, and at 0, we're going to be crossing the x-axis, and at x being 2, we will touch the x-axis. So, that means at -1, we cross the x-axis. We're going to have to make our way back to get to the next x-intercept. At 0, we're supposed to cross the x-axis again. And of course, we're going to have to make our way back at some point. And at 2, we're supposed to touch the x-axis. This is a place where I want to point out that when you're looking at all of these clues that you've created for this function, they shouldn't contradict each other, which means that you should be able to plot these points with this behavior, with this end behavior, and have nobody contradicting anybody else. So that means that I should have, if I'm looking at just checking my work here, I should have that my graph should go up on the far left and the far right, which it does. Good. I should have that I'm crossing the x-axis at 0 and at -1. I crossed at -1, I crossed at 0. Good and good. The other thing that I would have to have is that I'm supposed to touch the x-axis when x is 2. And we can see that when x is 2, yep, I touched the x-axis, I didn't cross it. So that means that I have fit in all of the clues. I have all of the zeros with the right end behavior and the right behavior at the x-axis at those zeros. So in other words, I have graphed g of x. If you find that things are contradicting each other, if you find that you can't put together the zeros with their x-axis behavior along with the end behavior and have it all work out as one smooth continuous curve, then that means you made a mistake. So as an example, and here I'm just going to show you what I mean by that, suppose that we instead were graphing and we made a mistake. And my mistake was this. Let's pretend that when I graphed, I had the wrong end behavior. So let's pretend that I thought my end behavior should have been something like this. If I try to now fit in what I have on my graph, putting in my x-intercepts with what I think I have as the end behavior, I'm going to run into a problem. Because if I try to cross at -1 and cross at 0, then I find that I'm forced to cross when x is 2. This is what I mean about things contradicting each other. If you get the wrong end behavior, then you'll find that you won't be able to do all of your x-intercepts with the correct x-axis behavior. If you have the wrong x-axis behavior, then your end behavior won't be able to match up with what you have. This is how you know that you've made a mistake. If I were looking at my graph here and I went back and said, oh wait, I was supposed to touch when x is equal to 2 and I didn't, that's a sign that one of my clues or more of them is wrong. And in this case, what was wrong was that end behavior. So now let's correct things. The correct end behavior, as we said, since the leading term was x to the 6, would be us going up on both sides, up on the far right, up on the far left. And if we put in our points with our end behavior, going up on the far right, going up on the far left, then we can cross at -1, cross at 0, and touch at 2. And there we go. That's my g of x is x cubed, x minus 2 squared, x plus 1. All right, let's do one more here. For this one, I've given ourselves a little bit of a shortcut in that it's in factored form, but I've also given the same polynomial in expanded form. So right away, we can do two things. I can say from the expanded form, you can see that the constant term is +3. And since the +3 is the constant term, then that means that that should also be the y-intercept. That the y-intercept should be the point 0, 3. And now the other part that we have is the leading term of x to the 4, negative x to the 4. That tells us that the end behavior for our graph should be the same as the graph of y equals negative x to the 4. X to the 4 goes up on both sides. Negative x to the 4 would go down on both sides. So for our graph, we're expecting it to go down on the far left and also down on the far right. And then finally, we have our zeros, our multiplicity, and our behavior. So we have three x-intercepts. X-intercepts when x is 1, when x is -1, and when x is 3. You can see that one of these, when x is 1, that comes from the factor x minus 1 squared. That has multiplicity of 2. The other two zeros come from x plus 1. That has multiplicity of 1. 3 minus x, that only shows up once. So that means when x is 1, we are going to touch the x-axis, but that we're going to cross the x-axis at the other two intercepts. Okay, and so now, as I said before, we're going to plot all of our points, fit in our end behavior, and then fit in our behavior at the x-axis, and that nothing should contradict any of the other facts that we've got. So that means we should be able to do the behavior at the x-intercepts as I've written them, with the end behavior that I've written down, and also passing through the y-intercept that I've shown. So the y-intercept, that was the point 0, 3. We also had x-intercepts at 1, -1, and 3. We also knew that our end behavior was down on both sides, down on the far left and down on the far right. So to the left of the furthest left x-intercept, we're going down. To the right of the furthest right x-intercept, we're also going down. And then now we'll fit things in using what we have for our behavior. At -1, at that point we're supposed to cross the x-axis. And then at 1, that's where we'll touch the x-axis. And then at 3, that's where we'll cross the x-axis again. So we're supposed to cross the x-axis at -1, which makes sense because we have to make our way up to that y-intercept. And we're going to make our way down. And we're supposed to touch the x-axis at 1. And we're supposed to cross at 3, and that actually makes sense because as we make our way back to 3, we see that yes, indeed, we are crossing. And so now, just to confirm that we've fit in all of the things that we need. Number 1, the y-intercept of 0, 3. Yes, we've got it. Correct end behavior, going down on both sides. Yes, far left and far right, we're heading downward. We're supposed to cross the x-axis at -1 and 3, and you can see that we do here and here. We're supposed to touch the x-axis at 1, and yes, we do there as well. So this is, again, the correct shape of my graph of f of x. And so now I'm just going to label my function. So that's x minus 1 squared, x plus 1, x minus 3. Now, there is some places, like I said, where we're not totally sure as to what's going on with our graph. And I just wanted to mention that again here, that I've drawn it and it makes it look like the y-intercept happens to be the turning point. That may not necessarily be the case. Our graph may go through the y-intercept and then actually have its peak a little bit later. Or it might turn out that our peak was a little bit before that y-intercept. Same thing with the peak between x is 1 and x is 3. Maybe it's this little shallow peak that I've drawn here, but it's also possible that it's much taller or much flatter. And there's no way for us to be able to tell without using calculus or taking a bunch of test points. And we're not interested in taking a bunch of test points, and we haven't learned calculus. So that means that this may not be a perfect representation of what f of x looks like, but this should still be the same overall shape of what f of x looks like with all the important points, the x-intercepts and the y-intercepts. Okay, so last one that I want to do here is kind of going in reverse. This is starting out with a graph and then coming up with a polynomial function that would have that graph. So a couple of things that we'll need to think about here would be, number one, where are the zeros and what's the behavior at those zeros? So there's three x-intercepts for sure. There's the x-intercepts at -2, 0, and 3. So if you're thinking about a function, there should be an x, there should be an x plus 2, and there should be an x minus 3 in there somewhere, because those would be the factors that would give you x-intercepts of 0, -2, and 3. And then now we have to think about the fact that these x-intercepts, some of them we're crossing. We're crossing the x-axis at -2 and at 0, but at one of them we're touching. We're touching the x-axis at 3. That means the powers on these factors need to be odd, and the power on this factor needs to be even. This is where we'll be able to come up with more than one correct answer. So I'm going to do this with the odd powers of, I'm choosing 1 and 1, and an even power of 2. So this would be an example of a function that would have this shape. You could also confirm with this that this has a leading term of x times x times x squared, or in other words, x to the 4. So the end behavior should be going up on both sides, and that matches what we have in our little graph that we've got going on there. So this would be correct. This would be totally fine as an answer. But it's also true that you could use other powers and come up with another answer that's also got that same overall shape. So as I said, you could have chosen to use odd powers 3 and 5, let's say. It would still give you something with the same overall shape. You would still be crossing at 0 and crossing at -2. You would also be able to confirm that for that, the leading term would be x to the power of 10, in which case, again, the end behavior would have you going up on both sides. So this is what I mean by, can you come up with an equation? Because there are not just one, but multiple answers, and in fact, infinitely many. And just like I changed these powers from 1 and 1 to 3 and 5, and it still worked, the power of 2 could have just as easily been changed to power of 4 or any other even power. Also, if I multiplied this entire function by a positive number, that would just stretch it vertically, but it wouldn't change the end behavior and it wouldn't change the x-intercepts. So that's another way to generate yet another equation that has that same shape. So this is my answer, x times x plus 2 times x minus 3 squared. But keep in mind there are infinitely many correct answers to this question. For the next one, I'm going to call this g of x. And same sort of a thing here. I'm going to start out with looking at those x-intercepts. So we have x-intercepts at -1 and at 1 and at 2. So as far as factors go, there should be an x plus 1, there should be an x minus 1, and there should be an x minus 2. I'm just going to give myself a little bit more room here. And if we're looking at the x-intercepts themselves, you can see that we're touching at -1 and we're touching at 2. So that means the x plus 1 needs to have an even power, and the x minus 2 also needs to have an even power. We're crossing when x is 1, so x minus 1 needs to have an odd power, which it does. I could, again, choose x cubed or any other such number, and that's odd, and that would also work just as well. So we have something that will have the same x-intercepts and the same behavior at the x-intercepts. We just have to make sure that what I've given you here has the same end behavior as the graph that we've got. And so for that, that's where we'll need to stop and have a little bit of a look at our leading term. And if you were to look at the leading term, you run into a problem, which is that the leading term is x to the power of 5, which should have end behavior of going up on the one side and down on the other. And that's actually the opposite end behavior that I've gotten going on my graph here. But I can fix that because I know that a vertical flip would give me the correct end behavior. So what I'll do is I'll just multiply g of x by -1. That means that my leading term would be -1 times x squared times x squared. In other words, my leading term would now be -x to the 5, and that should go down on the one side and up on the other. Yes, so this is something that would have the same end behavior as the graph that we've been given, and it also has the same x-intercepts as the graph that we've been given, with the behavior at the x-intercepts for the graph that we've been given. So again, one possible answer is the g of x that I've given, but I could use any other even power for those x-intercepts where we're touching the x-axis and get a graph with the same shape. And I could also use any odd power for that factor of x minus 1 and also get a graph with the same shape.